So, hello all. Chijoke here. We are going to work with the simple machine learning classification using random data. So we are going to use logistic regression for our classification, and we're going to generate random data for that. So we're going to use the IPython tool. It's one of the tools used for data analysis and also for machine learning. So we begin by importing the modules that we need. So I will launch the IPython. So this is the launching of the IPython. Exactly. So we are going to import the modules that we need, NumPy and NP. And then we are going to use pandas as PD. And then which other modules? We are going to use the sklearn, the scikit-learn for the classifier, so the logistic regression. And then the matrix also from that sklearn. So for our accuracy score, our mean squared error, and our mean absolute error. So it's loading gradually, it will soon appear. So from our sklearn, it's actually a linear model. So our logistic regression, and then our matrix for accuracy score, our mean squared error and absolute error from sklearn, that matrix. So we're going to use accuracy score, mean squared error, mean absolute error. Then also from sklearn, model selection. So we are going to use this train test split to split our data sets. So one thing in machine learning is that you don't want to use all your data for the trainings, so that you avoid generalization. So you split it in ratio of like 70-30 or 60-40. So 70, for example, can be used for the training of the model, and so the model has not seen the 30% of the training test. So it's going to use that for the validation before you now use it for the test set. So we are going to use the import random. Use this model to generate random data. So look at the data set we are going to generate is random. We are going to round it up. So what happens here is that we generated a random data, multiplied it by 100, and then rounded it up to 2 decimal places. And the number of the data that we generated is 50,000 data sets. So let me explain what happens. So this is random data. This is a random data. It's a random data. But we want it to be, they don't want it to be in less than 1, we want it to increase. So that's why we multiplied it by 100. So something you have like some 53.58 exactly, something like that. So the number changes because it is generating a new number. Every time it's a random number. So we want to round up this number to 2 decimal places. So that is why we use this function. Round random multiplying by 100 and 2 decimal places. I think so. So that's why it has rounded up. So for example, this is, if you are at 53, it goes to 53.58. In this case now it's 1.02. So we want to generate this number, 50,000 of this number. And then when we generate it, we want to also shape it to be, because we want to have columns and also rows from this 50,000. So first of all, we convert this data frame. What is let's check what's the type of this data. This data is in list. So but we want to change it to an array, and to the NumPy array. So we're going to say data is equals to np.array of data. So If you check the type again now, it has changed from list to numpy array. So let's see. So it has its own indexes and its own indexes. Exactly, the numpy array has its indexes. So we want to find the index that has the minimum value in the data frame, in this data. So we could say data arg of the minimum, the one that has the minimum. So the index of 784 of this 50,000 has the minimum value. So for example, if you say data of 784, this is the minimum, and you can see it's actually 0. So if you do the same operation for the maximum, this index 25333 has the highest. So if you check this 25333, this is the highest, and it's 100. So the least is 0 and the highest is 100. So you are going to put this data, this numpy array, into a data frame. And for us to do that, we want to resize it. It's 50,000 data points. We want to have 10 columns. So it's going to be 50,000 divided by 10. So it's going to be 5,000 rows and 10 columns. So we are going to create our data. Is equals to pandas.data frame, and then mp.resize. We resize it to 5,000 rows and 10 columns. So if you say data df.shape, no, it's wrong. Exactly. So you see that it's actually 5,000 rows, 10 columns. So let's see how this data frame is. So you have data df. Let's see the head of this data frame. See, so we have 10 rows, and this is just the first 5 rows of this data frame. The first 5 rows. So we want to calculate the sum of this data set and then create a column for that. So it's going to be data df for sum is equals to data df.sum, and the argument we placed inside that method of sum is axis 1. So we want the summation of the sum to be along the columns. So 0 is rows, 1 is column. So this is along the columns. So it's going to sum 78.69, 50.66, 2.75, 3.65, as the case will be till 9, and gives us the value. And it's going to create a new column, which is called the summation column, the sum, and you're going to append it to this. So this is what this function does. So if you check this data again, df.head, there's a new column now. The new column is sum. We have already added it. Then we are going to we want to generate like a sort of the column. So we have features and we have target. We want to generate a target column that are in zeros and ones. So we are going to create a condition for that. So this is a helper function. Helper functions are like functions that you put in operations functions you use to work on a data frame, so that you can perform that operations on several rows or several columns of the data frame. So in this case now, what we want to do is that we want to, if the number of the data is less than 500, so for example, this is the sum. if the sum is less than 500, we want it to return 0. If it is greater, else, if it is greater than 500, it's going to return 1. So for example, we want a new column where this is 447 is less than 500, so it's going to return 0. 451 is less than, so it's going to return 0. 548 is greater than 500, it's going to return 1. 1 and then 0. We want to use that for our target column. So this is the target function. So we are going to create a new target column called target. We are going to apply that function. So we are going to apply that function on this single row. You don't want to apply in the whole of the data frame. We just want to apply it on the sum, because that's the column you are working with. So it's going to apply this function target, which we have already created here, and it's going to append the results of that into a new column called the target column. So if you check our data frame head, it's going to give you a new column, and as you can see what I just said now, these ones are less than 500, that's why it's 0. This one is greater than 500, this is 1. So let us calculate how many of our data sets, the summation for each row, how many of them are equal to 1, the target is equal to 1, and how many is equal to 0. We guess, because it's a randomly generated data, there should be an almost even distribution of the data. So almost 50-50. But let's just see. So what will be the length of the data frame if the target is 1? 2512. So if it is 0, we have 2488, close to 250. So if you check the length of the data, so we have, so let's just say 2512, which is the one we generated, or let us just run it. Divide this by the length of the data frame. It's close to 50, 0.49, close to 50. And if you check also this one, if it is supposed to 1, it's close to 50. So it's an almost even distribution of zeros and 1, 50-50. So we have our columns here, and then the sum and the target. But you see that our columns and are numbered zeros and 1, they don't have names. So for example, if you look at this data frame.head, the columns of the data. So we have 0 to 9, then sum and target. We want to change this because these are our features. So we want to number it to be features that begin features from. So there are 10 features. So for us to do that, we do data frame.df is equal to data frame.rename. So what we do here is that we rename the first column, which is 0. We rename it to feature 1, the one that is 1 to feature 2, the one that is 2 to feature 3, that indicates the return the last value. And the operation is done so we have 5 to feature 6, 6 to feature 7 till 10. And the operation is done on the row. Remember, axis, the 0 axis is the row column, and then the one axis is the column. So we have the rows and the column. That's what I mean. So the 0 is the operations performed on the row, but if it is 1, the operation is performed in the column. So we want to change this because these are on the columns, not these ones here that are on the rows. So we're changing this to feature 1, feature 2, feature 3, feature 10. So if we run our data frame again, .head, it has changed. Our features have changed from 0 to 9 to feature 1, feature 2, feature 3, to feature 10. So now we want to do the proper machine learning now, but we want to get our features and our targets.